In this video, I'm going to walk through some brief examples using the tables within the AdventureWorks database to demonstrate how to work with null values, how they appear in output, and how to account for them, given that SQL relies on a three-value logic system where conditional statements can evaluate to true, false, or unknown. Again, different from a two-value logic system where it's either true or false. So going to set my current database, execute that statement. You can see it's up here. And then we're going to work with the person table in the person schema. We've kind of worked through this example already as part of a homework exercise, but kind of want to dive into that a little bit more, demonstrate it, and cover that. Everyone, in my experience, when I've asked that question, it's kind of an aha moment, and everyone seems to understand that null values ultimately aren't accounted for when you're evaluating non-equivalence. When you're trying to say, is something not true, that's not going to return a null value unless the null value is specifically requested. And that's the portion we're going to cover in this particular lecture. So we're going to select values for the field title. We're going to count them. So because we're performing an aggregation function across values in a field, we'll need the group by, and then we're ultimately going to order those results by values in the title field. Recall that this table, we can look at it briefly, contains some high-level personal information, first name, last name, middle name. We'll select the top 1,000 records. And we'll see, obviously, there's a key or an ID number. There's a title field, first name, middle name, last name, suffix, and then an email promotion field. So going back to the script, we'll run this. We'll see what are the possible values for the field title. And we can see that there are 7, including the null value or missing or unknown value. And recall that this field, if we weren't to perform an aggregation function, this field with these records, right, the distinct values could be returned with a select distinct title from this table. And so we have the same number of records essentially. So we have all possible unique values for all possible values for the field title, and then also the number of times they appear in the table source. So we can see by and far the null value is the most common value for that field. And if you think about that, right, this is probably some sort of form that folks are going into and entering information. You can imagine that the first name and last name fields are required, so you probably wouldn't find a null value in those fields. And then also probably going to find null values in a suffix field or a title field and even a middle name field if those fields are optional, right? Not a lot of people ultimately use a title or, for that matter, just populate an optional field. So that's probably the reason that you would see so many null values. And so what happens when we want to essentially return those possible values that are not equal to Mr. And you'll notice that when we're looking at the output right now, if we were to say, okay, under a two-value logic system, what's, Mr., this would be a true. What is not true would be this record, and then also the remaining records. However, SQL's three-value logic system is going to evaluate the null as unknown, and so it's not going to be false. It's not going to be not true, in other words. So we will only see these records returned in the output. Introducing the where clause here to essentially use records from the table source where that value is not Mr. In the processing of the query. So we'll run this. And we'll see, as expected, those last 5 records were the only ones returned. So how do we ultimately, if we want to include a null value in that logic, how do we do that? So that's accomplished through the OR, through an OR compound condition, and then also with the isnull keyword. And so here I put parentheses around this OR compound condition, even though in this particular case it's not necessary. But the reason that I do that is just practice, best practice, I think. Anytime you use an or, go ahead and put parentheses around what you want there, because that or data type or operator ultimately takes a lower precedence or is processed later than other conditions, such as and, which is the real big one that hangs these sorts of evaluations up. So that's why I ultimately included the parentheses. Notice we need the isNull keyword. We cannot use an equal sign here. We won't get the results as expected. So introducing this clause here is going to give us the 6 records, right? We're going to include the null values here in the output, which is what we would get under a 2-value logic system. And so that this is the way essentially to handle null values. And it's always good practice to assume that null values might exist in a field. And do you want those returned if you're evaluating a statement of non-equivalence? So we'll see that the null value ultimately is returned when we include it or explicitly request it in the query. I can show you if we were to do equals null or equals null, sorry, or title equals null, that it won't be returned. The null values won't be returned. So we need to be careful, right, that we always use the is keyword when working with null. And then I ultimately want to show that we can customize null values in the output. I'll rerun this to display what some value that a user-defined value. With the isNull function, takes the first argument as the column or field or values that you want to evaluate for null values, and then the second argument is what value to replace that null value with. So in this case, we're going to return the value unknown. We have a group by, right, because we're counting. This isn't a field, right? Sorry, this isn't an original field in the table source. This is going to be different. Nonetheless, we can't use column aliases in the group by, so we have to supply this full field, essentially a modification of an original field in the group by, and then we also need to order it by the new column alias. We cannot order it by the original field because the value unknown doesn't exist in the original table source. So evaluating output and ordering it that has different values from the table source isn't going to work. SQL is going to encounter an error. Nonetheless, the way the query is written here is going to process correctly, and we can show that the issues when we don't follow the rules in the group by or order by clause. What we will see is that null value record is ultimately transformed to a different value, unknown, and it has that same number of records. Notice that it appears at the bottom now because the value is no longer null. Null value would appear at the top of an ascending sort, but because now it starts with the letter U, that's the last value alphabetically. So it appears at the end. So let's go into the group by clause here and just see what would happen if we were to use a column alias. All right. It's going to return an error. We do know that. We can't use column aliases in a group by. So it basically tells us that it's an invalid column name. I do know if I use single apostrophes, it returns a slightly different error, but the error is essentially the same. It's essentially acting as though this is an outer reference, which means that it doesn't exist in the table source. And so that is why we ultimately have to replicate anything we do in the select list, if it's a grouping criteria, within the group by statement. And that's why ultimately, if you imagine a case statement, if you're grouping by those values, that's why the group by clause can get pretty long pretty quick. But just important to know that you can't use column aliases in the group by. And then finally, the order by clause here, it's going to have, if we were to just order it by the field, the original field in the table source, we're going to get an error because it will not know what to do with this value, which doesn't appear in the table source. So we'll execute that, and we'll get an error telling us it's invalid in the order by clause because it is not contained in either an aggregate function or the group by clause. So that is a little bit of a different error than you might expect because you're kind of expecting it in this group by, right? But what it's telling you is if we were to if we were to do this, right, and add it to the select list, in which case means we need to add it to the group by list, right, because it's a field, not an aggregate function. We can then order by title because it appears in the output. So SQL will know how to do that. But because we're ordering it by title, that null value this is the field that it's sorting on. That record's going to be returned first because nulls appear first in the output. So just a few little notes there on working with a function, a modification of a field, how it needs to appear in a group by, and then also how it should be used in an order by. The nullif function, super useful if you were possibly going to encounter a divide by zero error. Right, and this should be straightforward enough. You would think that you would know that you're going to have a divide by zero, and you might not actually work with fields that have zeros at all. But this can occur, right? If you were to have something in the denominator that is a case statement, or something that is evaluating these fields or values across one or more fields, and you don't ultimately know if there's going to be a zero, or imagine if you were using a count function and there aren't any records that meet a certain criteria, that implies or means that the denominator is going to be zero, and you're going to encounter an error when you run the query, which is really frustrating. It's like, how do I get rid of this? And some people end up like changing values of 0 to something very close to 0, so 0.0001, which is fine. But this ultimately returns a null value if the value is 0. We can see here ultimately, and we've seen this before, that there's a divide by zero encountered when you a divide by zero error encountered when you divide by zero in SQL. Other languages might be able to handle it, but SQL cannot. And so what happens when we supply a null if instead? We're basically saying if the values in the two arguments match, then we'll return a null. And so 1 divided by null ends up returning a null. So we see here that we don't have an error. And so that's what essentially this nullif function is doing in this particular example. And so we ultimately can process that query. Now, your nullif in practice would not be 0, 0, because this is basically saying if the first value equals 0, then return a null. So it's always going to return a null in this particular example. However, in practice, this first argument would normally be a field, something that could possibly be 0. And so your second argument would still be 0, and it would basically say the function would work and evaluate that field or combination of fields that could possibly be 0, and then say, when it's 0, return a null. And so at the end of the day, you're dividing 1 by null and not 0, and so you can return a value in those cases. And that's why it's very useful when you might have divide by zero errors. And that concludes the examples that I wanted to review with null values, working with null values, and then also working with the isnull and nullif functions.